Hey everyone, and welcome back for another deep dive with us. So this time we're looking at something pretty wild.
Yeah.
NASA's plan to come up with a whole new way to tell time, but on the moon.
Huh.
So,
Pretty crazy.
yeah, we're basing this whole thing on this really interesting article from Universe Today.
Okay.
It just came out last week. It's called NASA's Plan to Rewrite Time for Space Missions.
Nice.
And, it's not just about like setting clocks on the moon. It's not that simple.
Right.
It gets a lot more interesting when you start to think about Einstein's theories of relativity.
Oh, yeah.
And that whole idea that time can actually be different depending on where you are.
Yeah, and how fast you're moving.
Exactly. Like, how crazy is that?
Yeah.
So imagine trying to coordinate lunar rovers and habitats and even people from different countries working together on the moon,
Right.
all while time itself is kind of
Out of sync.
out of sync. Yeah.
It's really interesting, isn't it? We always think of time as this constant thing, this universal thing. But when you start thinking about space exploration, especially what we're thinking about now with moon bases and even a moon village,
Right.
the way we tell time here on Earth just doesn't work anymore.
Yeah, it's almost like we're entering this brand new era of timekeeping. When people first started sailing around the world.
Yeah.
And they had to figure out time zones and how to standardize everything.
Totally.
But before we get too far ahead of ourselves, let's take a step back.
Okay.
What is the main problem that NASA is trying to solve here?
So basically the problem is one of precision and coordination.
Okay.
As we start doing more and more on the moon, like building bases and habitats, doing experiments, even commercial stuff,
Right.
there's going to be so much activity on and around the moon.
Yeah.
And all of it has to be coordinated perfectly between the moon, its orbit, and Earth.
Mm-hmm.
And right now, we just don't have a way to tell time that's accurate enough for that.
So you're saying the timekeeping systems we use now for things like GPS or scientific research, those aren't good enough for the moon?
Yeah, they're not good enough.
Why is that?
Well, even really advanced systems like terrestrial time are still tied to Earth.
Oh, okay.
They're meant to work within Earth's gravity, and they don't fully account for the differences in how time flows on the moon.
So there are actual differences?
Yeah, because of the moon's weaker gravity, and because it's always moving around. The Earth clocks on the moon tick a little bit faster than clocks here on Earth.
Wait, hold on. Are you saying time moves differently on the moon?
It does.
I thought time was a constant.
Well, that's where Einstein and his theories of relativity come in.
Okay.
He totally changed how we understand time.
Mm-hmm.
He showed that time isn't absolute, it's relative,
Oh,
meaning both gravity and motion can affect how time flows.
so even tiny differences in timekeeping could cause big problems for lunar missions in the future.
Exactly. Imagine a lunar rover that misses its meeting point because of a tiny time mismatch,
Oh.
or a science experiment gets messed up because the timing is off. These might seem like small problems, but when you're dealing with the distances and complexities of space exploration, they could have huge consequences.
So how is NASA going to fix this?
No.
Are they seriously going to invent a whole new way to tell time?
Typically, yeah.
Wow.
Researchers at NASA's Jet Propulsion Laboratory, JPL for short, have proposed a new system called Lunar Time, or LT.
LT.
It's kind of mind-blowing that we need a special time system for another world.
I know, it really shows how far we've come in space exploration.
Yeah.
But how would lunar time actually work?
Okay, so imagine you have two identical clocks.
Right.
One on Earth and one on the moon.
Got it.
Because of the difference in gravity, the clock on the moon will tick slightly faster.
Okay.
Now, this difference is super small, but over time it adds up.
Right.
Lunar time would take this difference into account.
Okay.
It would use something called relativistic time transformations to make sure the clocks on the moon stay in sync with the ones on Earth.
So that makes sense, but it sounds incredibly complicated. How do they even start to figure out those tiny time differences and then actually build a system around them?
It's really amazing, a combination of engineering and scientific teamwork.
Wow.
One of the key things is using very precise data from past missions.
Okay.
For example, the Gravity Recovery and Interior Laboratory mission, GRAIL for short,
Real.
mapped the moon's gravity field in incredible detail.
Wow.
And then there are the lunar laser ranging experiments that have measured the distance between the Earth and the moon down to the millimeter.
That's insane.
By combining all this, data scientists can create a really accurate model of the moon's gravity and how it moves in orbit.
Huh.
And that's how they can figure out the specific time difference.
It's amazing to think that something as simple as telling time needs so much data and scientific precision.
Yeah, it really highlights the level of detail needed for space exploration. And this isn't just theoretical. Having this precise lunar time is going to be crucial for all sorts of things we do on the moon.
Like what? Give me some examples of how lunar time will be used in real life.
So picture this: mission control is coordinating a lunar rover exploration.
Okay.
With lunar time, they can plan the rover's movements down to the second.
Okay.
So it reaches its destination at exactly the right time, even with that slight time difference between the Earth and the moon.
So instead of the rover being a little early or late because we're using Earth time,
Yeah.
it would arrive at the perfect moment even though the moon's time is flowing a little differently.
Exactly. Or imagine trying to land a spacecraft on the moon.
Okay.
Even a small timing error could mean missing the landing zone by miles.
Oh, wow.
With a precise lunar time system, we can make sure that spacecraft land safely and exactly where they're supposed to.
That makes sense.
And it's not just rovers and spacecraft.
Yeah.
Lunar time will be important for everything we do on the moon, from coordinating science experiments to managing communication networks, even scheduling daily life for people living there.
It really feels like we're on the edge of a whole new era of human life on the moon. One where we need entirely new systems and ways of thinking to deal with the challenges of this environment.
You got it.
Yeah.
It's a sign of how far we've come in space exploration, but also a reminder that we still have so much to learn and adapt to as we explore the cosmos.
It makes you wonder if we're already making a new time system for the moon. What happens when we go further? What about Mars or even beyond? What other mind-blowing challenges and discoveries are out there?
That's something we'll talk about in the next part.
Okay.
But for now, it's pretty amazing to think that something as basic as time, something we take for granted, becomes a whole new frontier when we leave Earth.
It's a great reminder that exploration isn't just about physically going to new places.
Right.
It's also about expanding our knowledge and understanding of the universe.
Totally.
And who knows, maybe these new ways of thinking about time will change how we see our own lives and our place in the universe.
Interesting thought.
Yeah.
It really is.
All right, let's take a quick break and then we'll come back and dive into those bigger questions.
Sounds good.
Yeah.
It is fascinating, isn't it? Like, the further we go out into space,
Yeah.
we might find that some of the things we think are totally normal here on Earth, like
Right.
time, we have to rethink them completely.
Absolutely. It's like we're rewriting the rules as we go along.
Yeah.
But I'm curious, so we're making this new time system for the moon. What does that mean for everyone else? Are other space agencies thinking about this too?
Oh, yeah, definitely. This isn't just a NASA thing.
Okay.
Well, the European Space Agency, they've been really pushing this idea of a moon village, this
Right.
international base on the moon.
Yeah.
And they've said that a standard lunar time system is super important for making sure everything runs smoothly in the village.
Right.
It's like creating a universal language for time.
Yeah.
For everyone's on the same page, no matter where they're from.
It makes sense. You can't have different parts of the base working on different time zones.
Exactly.
That would be total chaos, especially when it comes to important stuff like scientific research.
Right.
So it seems like the standard lunar time system is becoming more of a necessity than just a cool science idea.
Totally.
And it's not just about the moon village. As more countries get involved in lunar exploration like China and Russia, this need for a global lunar time is only going to get more important.
Yeah.
Imagine trying to coordinate a rescue mission or share important scientific data when everyone's using different timescales.
That would be a nightmare.
It's kind of like those early explorers on Earth when every country had its own maps and navigation systems.
Yeah.
Eventually, they had to come together and create standardized systems for global trade and exploration.
Right.
It seems like we're doing the same thing now, but on a cosmic level.
That's a great comparison. It's like we're the pioneers charting a new course for humanity in space.
Yeah.
Where people aren't just visiting, but living and working together. And to do that, we need new ways of thinking and new systems that can handle the challenges of living in space.
So speaking of challenges, let's get back to how lunar time would actually be used. We've talked about coordinating missions and experiments.
Right.
But can you give me some more specific examples?
Sure. So imagine you're a scientist on the moon studying lunar geology.
Okay.
You and your team are collecting rocks, analyzing data, running experiments in different locations.
Right.
But if your clocks aren't perfectly synced, it's almost impossible to compare your findings.
Yeah.
It'd be like trying to put together a puzzle where the pieces don't quite fit.
A scientific nightmare?
Exactly. But with lunar time, all your instruments and data would have accurate timestamps,
Okay.
making collaboration much easier and the research more reliable.
So it's not just about science then?
No, it's also crucial for navigation and safety.
How so?
Well, think about guiding a spacecraft into lunar orbit or landing a rover.
Mm-hmm.
Those maneuvers need perfect timing.
Right.
Even a tiny error could mean disaster.
Exactly. With lunar time, mission control can make sure everything happens exactly when it should,
Okay.
accounting for the time difference between Earth and the moon.
So lunar time isn't just about telling time.
It's about making sure everything we do on the moon is successful and safe.
Absolutely. It's about creating a system where things work predictably and reliably, even in this challenging environment.
Mm-hmm.
And in a way, it's also about pushing the boundaries of what we know.
Oh, okay.
Just like we used to think the Earth was flat.
Right.
Now we're challenging our ideas about time itself.
It's crazy to think about.
Yeah, it is.
So if time is relative and we're making a new time system for the moon, what about other places in space? What about Mars?
Right.
What time will they use there?
That's where things get even more interesting. Lunar time is really just the beginning.
Okay.
As we go further out to Mars, Saturn's moons, even beyond our solar system,
Yeah.
we're going to encounter even more extreme differences in gravity and motion.
Right.
This means that every new world we explore
Mm-hmm.
will probably need its own unique time system.
So we could have Martian time, Jovian time, even interstellar time.
Exactly. It opens up a whole new dimension to exploration, doesn't it?
It does.
We're not just exploring new worlds.
Yeah.
We're exploring new dimensions of time and space, and maybe even new dimensions of human experience.
It's mind-blowing.
Isn't it? Imagine astronauts coming back to Earth after a long mission to Mars,
Yeah.
having lived on a totally different timescale.
Right.
It would be like stepping into another reality.
And it makes you wonder what other things we might have to rethink as we go further into space.
Absolutely.
Our understanding of distance, for example, completely changes when you're talking about the huge distances between stars.
Yeah. I mean, here on Earth, we think about distance in miles or kilometers,
Right.
but those units don't really make sense when you're talking about light years.
Exactly. And then there's communication. How do we even talk to each other across those vast distances,
Yeah.
especially with the time delays? A message from a spacecraft near Saturn could take hours to reach Earth.
It's crazy.
And what if we find other intelligent life that have their own ideas about time?
Oh.
It's both exciting and a little scary to think about all the challenges and possibilities. Yeah.
But it also shows how adaptable and clever humans are.
Definitely.
We're constantly pushing the limits of what we thought was possible, both physically and mentally.
Absolutely. This whole thing with redefining time for space exploration is a perfect example of that.
Yeah.
It's about pushing the boundaries of what we know and finding creative solutions to problems we never even imagined before.
Mm-hmm.
And who knows what other incredible discoveries are waiting for us.
Right.
Maybe we'll find life that experiences time differently than we do, or discover new laws of physics that change how we see the universe.
It's both exciting and a little humbling to think about.
It really is.
I think that's a great point to move on to our final segment,
Okay.
where we can talk about what the future holds for space exploration and our understanding of the universe.
Yeah, it's wild to think that going further into space could change how we see such basic things as time and distance.
One thing that could really mess with our heads is the idea of distance.
Okay.
I mean, here on Earth, we're used to measuring things in miles or kilometers.
Yeah.
But those units become practically meaningless when you're talking about the distances between planets and stars.
You're right. Even light years are tough to grasp.
It is tough.
And that's just within our own galaxy.
Right.
How do we even begin to understand those kinds of distances?
Yeah.
Let alone travel them?
It's definitely a huge challenge, and it's not just about how big those distances are.
Okay.
It's that as we start traveling farther and faster,
Yeah.
the whole idea of distance and travel time gets even more complicated,
Right.
especially when you consider Einstein's theory of relativity.
Okay, now you're really getting into some mind-bending stuff. Can you explain how relativity changes the way we think about distance and travel time?
So imagine you're on a spacecraft traveling at a good chunk of the speed of light.
Okay.
Now, according to Einstein's theory of special relativity,
Mm-hmm.
the closer you get to the speed of light, the slower time moves for you,
Wait, really?
compared to someone who's not moving.
So if I was on that spaceship, time would be moving slower for me than for someone back on Earth.
Exactly.
Wow.
You could travel these insanely long distances.
Yeah?
And for you, it might feel like only a few years have passed.
Huh.
But back on Earth, centuries could have gone by.
So it's like time travel.
In a way, it is. It's called time dilation.
Time dilation.
And it's one of the craziest things about relativity.
So future space travelers could come back to an Earth that's completely different from the one they left.
It's possible.
That adds a whole new level of complexity to space exploration.
Definitely. It shows that space travel isn't just about physical distance. It's about traveling through time, too.
Right.
And that brings up some pretty wild questions about the future of humanity and our place in the universe.
It's a lot to think about. So after this deep dive into lunar time and the crazy challenges of time and space in the future of space exploration, what would you say is the biggest takeaway for our listeners?
I'd say the most important thing to remember is this.
Okay.
As we explore space, we're not just finding new places, we're discovering new ways to understand time and space.
Yep.
And maybe even new ways to experience being human.
It's like we're in a new age of discovery where exploration isn't just about going places.
Right.
It's about pushing the boundaries of what we know and how we understand the universe.
Exactly.
And that's something that should inspire everyone, not just scientists and astronauts.
I agree. It should make us all think bigger and bolder about our place in the cosmos.
I love that. And who knows what amazing things we'll find along the way.
Yeah.
Maybe we'll find life that experiences time completely differently than we do, or uncover new laws of physics that change everything we thought we knew about the universe.
It's exciting and humbling at the same time.
It really is. It makes you realize that even something as simple as telling time can show us how vast and complex and amazing the universe truly is.
Yeah.
And as we keep exploring, we'll keep learning more, challenging our ideas and expanding our horizons.
That's what makes this journey so incredible. There's always something new to discover, always another layer to uncover.
Well said. And I think that brings us to the end of our deep dive into lunar timekeeping, time dilation, and the mind-blowing challenges of navigating time and space as we explore the cosmos. It's been an awesome journey.
It has been. And it's just the beginning.
To our listeners, thanks for joining us. Remember, the universe is full of mysteries waiting to be discovered.
So many mysteries.
So keep looking up, keep asking questions, and keep exploring the frontiers of knowledge.
Until next time.